All right, let's do this. This is my first time creating a video this way. Normally I'm in the classroom, I'm surrounded by teenagers, and I wanted to try something different. So this problem that we're going to look at is a released AP Calculus question. This has been used previously on our fall semester exams, and this is an excellent review question to help you guys get ready for your exam next week. So you should have a copy of this in front of you, and I'm going to assume that you've already tried working through this on your own. Maybe you've hit some stumbling blocks along the way, and we're just going to compare your work to mine. We'll see how it goes. Consider a function f of x of the form f of x equals 1 over x squared minus kx, where k is a non-zero constant. Okay? In part A, they tell us that k is equal to -1. So this expression, 1 over x squared minus kx, becomes f of x equals 1 over x squared plus x. F of x is 1 over x squared plus x. Determine and classify all asymptotes of f of x. Well, when it comes to asymptotes, in AP Calculus, we have horizontal asymptotes. And to find a horizontal asymptote, we take the limit as x approaches infinity of the function. And depending on the function, we also then look at the limit as x approaches negative infinity. For the vertical asymptote, we're looking for values of c such that if you find the limit as x approaches c of the function, your answer is going to be positive or negative infinity. That's the technical limit definition. And if this was a calculator active question, it would be relatively easy to type this function into the calculator, look at the graph, and determine the asymptotes. This is calculator inactive. So first I'm going to start by looking at my horizontal asymptote. Horizontal asymptotes, if they exist, are found by taking the limit as x approaches infinity of 1 over x squared plus x. Now, the denominator is quadratic. This is degree 2. The numerator is a constant. So the numerator remains the same. The denominator is quadratic. That is growing faster than the numerator. This limit as x approaches infinity of 1 over x squared plus x, has to be equal to 0. What that means is my graph is going to have a horizontal asymptote at y equals 0. That's all that needs to be done on this problem. If you consider the limit as x approaches negative infinity, because this is a rational function, you're going to find that you get the exact same horizontal asymptote. For vertical asymptotes, we start by setting the denominator equal to 0, and we're looking to see where does the denominator equal 0. Because whenever the denominator is equal to 0, your function would be 1 divided by 0, which is not possible. And so these are going to be your candidates. X squared plus x is equal to 0. I can factor out the x, which leaves me x times x plus 1 equals 0. If that product is equal to 0, then it means that x is equal to 0, or x plus 1 is equal to 0. Solving the second equation, we get x equals -1. If we were to take the limit as x approaches 0 of 1 over x squared plus x, the denominator is approaching 0, the numerator remains 1, 1 divided by something that is getting closer to 0, you're getting smaller and smaller and smaller and smaller, is going to approach either positive infinity or negative infinity, depending on which side of 0 you're approaching. Similarly, we can find the limit as x approaches -1 of 1 over x squared plus x. If we try plugging in -1, you'll get -1 squared, which is 1, plus -1, which is 0. Again, the denominator approaches 0. The numerator is 1. The denominator approaches 0. The limit is going to be positive or negative infinity. So we have vertical asymptotes at x equals 0 and at x equals -1. On the scoring rubric, I believe we awarded 1 point for identifying the vertical asymptotes and 1 point for identifying the horizontal asymptote. That's part A. Let's look at part B. In part B, now they've given us a different value of k. K is equal to 3. The function now is f of x equals 1 over x squared minus 3x. Write an equation for the line tangent to the graph of f at the point whose x-coordinate is 4. Well, I know that when we write tangent lines, we normally write them in the form L of x is equal to your slope times x minus x1 plus y1. This is just your point slope form. The slope is the value of the derivative at the given point, so f prime of 4. So in part B, I'm going to start, I want to find f prime of 4. That's a two-step process. The first step is to find f prime of x, find the derivative. Well, how am I going to find the derivative? The derivative of 1 over x squared minus 3x, we can use the quotient rule. The quotient rule says low d high minus high d low, low low. Low is your denominator. D high, the derivative of the numerator, well that's 0, minus high, that's the numerator, times the derivative of the denominator, all over low low, the denominator squared. X squared minus 3x times 0 is 0. And so we get negative 1 times 2x minus 3 divided by x squared minus 3x squared. This is f prime of x. We would have awarded 1 point for finding that derivative correctly. Now let's evaluate the derivative at 4. Just plug in negative 1 times 2 times 4 minus 3 all over 4 squared minus 3 times 4 squared. You can simplify this if you want to. There's absolutely no reason to, but let's do it anyway. 2 times 4 is 8 minus 3 is 5 in the numerator, negative 5. 4 squared is 16, 3 times 4 is 12, 16 minus 12 is 4, 4 squared we get 16. This value over here is your slope. We need to know the coordinates for the point. Well, that means I need the y value. To find the y value, I evaluate f of 4. So that's going to be 1 over 4 squared minus 3 times 4, which I believe is 1/4. This means that the point of tangency has coordinates of 4, 1/4. Writing everything together as my tangent line, we take the slope, negative 5 over 16, times x minus 4 plus 1/4. You would most likely get 1 point for coming up with the equation of the tangent line, 1 point for finding the specific slope, 1 point for finding the derivative using the quotient rule, or maybe you decide to find the derivative using the chain rule. That works too. No problem there. This should be a 3-point question. Let's keep going. Part C, last part. Find the value of k such that f of x equals 1 over x squared minus kx has a horizontal tangent line at x equals negative 5. Well, if I have a horizontal tangent line, that means that my slope is equal to 0, the derivative is equal to 0. But specifically, I need a horizontal tangent line at negative 5, so I need f prime of negative 5 to be equal to 0. Well, let's start it. What are we going to do? First, find that derivative. Again, using the quotient rule. Low d high, so times 0, minus high d low all over low squared, low low. Again, x squared minus kx times 0, that's all 0. In the numerator, I'm going to distribute that -1 through. We get -2x plus k. In the denominator, x squared minus kx, the whole expression squared. This is f prime of x. I believe we awarded 2 points for the derivative because it's a little more complicated here. What do I need though? I need the just right value of k such that f prime evaluated at -5 is 0. Find f prime at -5. That's -2 times -5 plus k over -5 squared is 25 minus k times -5 is 5k squared. Where is that equal to 0? Even considering this equation earns you a 3rd point. In order to solve this problem, well, what do we have? The numerator says 10 plus k divided by 25 plus 5k squared is equal to 0. If I have a fraction equal to 0, the only way that is going to be true is if the numerator is equal to 0, but the denominator is not equal to 0. So what I need is I need 10 plus k to be equal to 0. Well, that's easy enough. K is equal to -10. And that, my friends, is the value of k that we were looking for that made the derivative equal 0, which means we have a horizontal tangent line at x equals -5. That is worth 4 points. And that completes this problem. Nice job. Hope you learned a lot. Make sure to take some time to reflect on what you've learned, jot that down, and if you are a student at Southwest, turn your initial pass at this problem along with your notes from this video and a summary of 2 to 3 big takeaways for you, things that you learned in the process. Turn that into me so I can replace your lowest homework assignment with a 100.